Question 3b, Part 1. By expanding the left-hand side, show that sine of 5x plus 4x plus sine of 5x minus 4x equals 2 sine 5x cos 4x. Recall the compound angle expansion for sine A plus B, and that equals sine A cos B plus sine B cos A. We'll call that equation number 1. And also sine of A minus B is equal to sine A cos B minus sine B cos A, and we'll call that equation number 2. So taking equation number 1 and adding to it equation number 2, we'll find that we've got 2 of these sine A cos B terms, but sine B cos A will cancel with negative sine B cos A. That'll equal 0 when you add those two together. Hence, sine A plus B plus sine A minus B is equal to 2 sine A cos B, where A is equal to 5x and B is equal to 4x. Hence, sine 5x plus 4x plus sine 5x minus 4x is equal to 2 sine 5x cos 4x as required. Part 2. Hence find the integral of sine 5x cos 4x dx. The following are the marking guidelines for question 3b, part 2. For 1 mark, we have solution recognises the connection with part 1, and for 2 marks, we have correct primitive. From part 1, sine 5x cos 4x is equal to half times sine 9x plus sine x. Now we get the sine 9x by adding 5x and 4x together, and we get sine x by subtracting 4x from 5x. And the half comes from dividing both sides of this equation by 2. Integrating both sides of this equation, we have the integral of sine x cos 4x dx is equal to half times the integral of sine 9x plus sine x dx. Performing the integration, that equals half times negative 1 over 9 times cos 9x minus cos x. We can factorise out negative 1, so the integral is equal to negative half times 1 over 9 times cos 9x plus cos x plus the constant of integration c. The following is the feedback from the Marking Centre for question 3b. For part 1, this question was done well. However, a significant number of candidates made careless errors such as omitting 5s, 4s, x's. For part 2, generally this part was done reasonably well. Some candidates did not see any connection with the expression given in part 1. Others assumed that the expansion found in part 1 was the integral. Others did not recognise the need to find half of the expression in part 1 before integrating, and others assumed that sine 9x plus sine x is equal to sine 10x.